So hopefully after all the time that you guys have spent in here learning math, you've learned that mathematicians like having condensed notations. And it's a big part of what we learned in chapters 2 and 3 is just notation. And here we're going to get a lot of stuff like that as well, where when we're talking about events given other events, P of B given A, we can talk about this in terms of something called conditional probability, where A is providing a condition under which B occurs, or B kind of depends on A in some way. And to do that, we can draw that in with a little vertical bar, like so. So this P of B bar A can be read as the probability of B given that A has occurred. So for example, with those cards from before, we were talking about the king. We could say the probability of a king given a queen can be notated as the probability of the king and then vertical bar queen. So that bar just means given, which as we saw was 4 out of 51. For another example, we have that the table here shows the results of a survey in which 2,276 social media users were asked whether they have ever been offended by something they saw on social media. What we want to do is find the probability that the user is male given that they were offended by something on social media. So with this type of problem, the big thing to pay attention to is exactly how the table we're working from, if we're given data in this way, is formatted. In this case, we've got it broken down by 4 categories: yes, no, male, female. Where here, we are saying that we want to find the probability that the user was male given that the user was offended by something on social media. Inherently here, we're looking for some kind of conditional probability. The probability of male given offended. So for this problem, there's a lot of data that we can immediately ignore. All we want to focus on is whether or not they were offended first, and then from there, focus on whether or not they were male. So we're going to nail down that one first column, and then look at that the second row. See what the overlap is in there, and that will give us our probability. So, if we're thinking about the number of people who were offended, that's just 1,151. Again, we're only caring about the offended people. The unoffended don't matter for this case, even though that's another 1,125 people. And then from there, the males are just in that column, which would be 532 of them. And as a result, our probability would be 532 over 1151, or if you prefer, about 46.2%. So, we would say here that the probability of them being a male, given that they were offended, is about 46%, where it's important to notice here that if we ignore whether or not the person was offended, we would get a slightly different probability of 1106 divided by 2706. So, 2276. Well, it's a very different number. But the point is, we would have that the conditional probability of someone being male given that they're offended is different than the non-conditioned probability of them just being male, which is another characterization that we don't talk about too much here of those events having some sort of dependence relationship.